We have seen how quadratic equations are solved. Sometimes, day-to-day situations may arise where quadratic equations may be used to determine the solution. Let's look at an example. Anita is Neha's sister. Neha is younger than Anita by 7 years. The product of their ages is 144. Find their ages. Our first step here should be to identify the unknown quantities and check for any relationship between them. We can then convert the word problem into a quadratic equation and solve for the unknown variables. In this case, both Anita's and Neha's ages are not known. But we are given that Neha is younger than Anita by 7 years. So, if we assume Anita's age to be X years, we can say that Neha's age is X minus 7 years. There is yet one more relation between their ages. We are given that the product of their ages is 144. We can thus say that the product of X and X minus 7 is 144. Now, we have a quadratic equation in X. Our next step is to solve the quadratic equation formed. Splitting the middle term of this equation and simplifying it, we get the values of X as 16 or minus 9. Finally, choosing the appropriate solution which satisfies the given conditions, we interpret the solution in terms of the problem, that is, in verbal language. We have two possible solutions for X here. But since minus 9 cannot be the age of a person, this value does not satisfy the given condition. So, the correct value of X for our problem is 16. We had initially assumed Anita's age to be X years. We can thus say that Anita is 16 years old. Also, Neha is 7 years younger than Anita. So Neha is 9 years old. Now, you have seen how we made use of our knowledge of quadratic equations to solve a daily life problem. By following these 3 simple steps, let's try another example. In a 2-digit number, the digit at the units place is 1 more than the square of the digit at the tens place. If 27 is added to this number, then the digits get interchanged. Find the original 2-digit number. Here, we are given a relation between the digits at the tens place and the units place of a number. Let's assume that the digit at the tens place is X, as the digit at the units place is 1 more than the square of the digit at the tens place. We can say that the digit at the units place is X squared plus 1. We can thus write our number as 10 times the digit at the tens place plus the digit at the units place. So our number is 10x plus x squared plus 1. If the digits are interchanged, the new number will be given by 10 times x squared plus 1 plus x, that is 10x squared plus 10 plus x. Now, we are also given that when 27 is added to the original number, we get the new number with interchanged digits. So, we can say that the original number plus 27 is equal to the new number. This equation can be simplified to obtain a quadratic equation in X. Now, to solve this quadratic equation, we split its middle term and simplify it as shown. We get the values of X as minus 1 or 2. Since the digit of a number cannot be negative, we do not consider the value minus 1. Hence, the correct value of X for our problem is 2. Since our original number is given by 10x plus x squared plus 1, we can substitute the value of X as 2 in this equation. We thus get our original number as 25. Simple, isn't it? Now, take a look at this example. A stationer buys notebooks in bulk from a retailer. When the price of a single notebook goes up by 4 rupees, the stationer gets 10 books less than what he used to get for 800 rupees. Find the original cost of one notebook. In this case, we are given that the price of a notebook increases by 4 rupees. Let's take the original price of a notebook as X rupees. Then the new price of a notebook will be X plus 4 rupees. The number of notebooks that can be purchased for 800 rupees at the old price will be given by 800 divided by X. Similarly, the number of notebooks that can be purchased for 800 rupees at the new price will be given by 800 divided by X plus 4. We are given that the stationer gets 10 books less for 800 rupees at the new price. So, we can say that the difference between the number of books that can be purchased for 800 rupees at the old and new rates is 10. This equation can be simplified to get a quadratic equation in X. To solve this quadratic equation, we split its middle term and simplify it as shown. We hence get the values of X as minus 20 or 16. Since the price of an object cannot be negative, we do not consider the value minus 20. Hence, the correct value of X for our problem is 16. So, the original price of a notebook is 16 rupees.